Hello, this is Susan Poss. This is Math 102, also Math 101. I'm looking with you today at ways of solving quadratic equations by factoring. That is the first technique that a student learns for solving second-degree equations. And then if you're in 102, there will be, I think, 3 additional techniques that you will learn for solving a quadratic equation. But let's go ahead and get this first technique down. We're working with quadratic or second-degree equations. And when you have an equation that is a second-degree equation, the way you recognize that is you see a second-degree exponent, an exponent of 2 on one of the letters, one of the variables. And what that does is identifies it as a second-degree or quadratic equation, and you expect to get 2 answers at most for a second-degree equation. So the first thing I'm going to be showing you how to do is to make sure that you understand what standard form is. Standard form places the second-degree term in the first position, the first-degree term in the middle, some sort of a constant on the end, and then it's all set equal to 0 on the other side. What you and I will be doing as we work through this is trying to figure out a way to factor this left-hand side. The other thing we'll be using is something called the zero factor theorem, which says if you have 2 numbers that are multiplied together, and if that answer that you get when you multiply them is a 0 answer, then either A, in this case, had to be 0, or B had to be 0. So in order to produce a product of 0, one of the 2 factors had to be a 0 factor. So we're going to start out with the first type, which is already factored. We're starting with one where most of the work has already been done. So you'll check the left-hand side of the equation. You'll see that everything is on one side and you have 0 on the other. How do you know this is a second-degree equation? Well, you can see that if you started multiplying this back together, that first term would be a second-degree term. Now, that's not the way we want to go, but I just wanted to show you that that is, in fact, a second-degree equation. So how do you go about solving a second-degree equation? Well, you want to factor the left-hand side. And in this one, it's already factored. So the second thing we want to do is take each factor. So the first factor is x minus 7. The second factor is x plus 2. And we're going to set each of those equal to 0. This is using the zero factor property that says if you have 2 things multiplied together and you get a 0, one of those 2 things had to be a 0. So as I solve this, adding 7 to both sides and here subtracting 2 from both sides, I can see that I have 2 answers. The first answer is 7, and the second answer is -2. So usually you'll see this written maybe with the 2 answers separated with a comma. So that's the way you work the first one. The second one is also already in factored form. So I'm going to scroll up just a little bit here. Since it's already factored and already set equal to 0, I'm going to take the first factor and set it equal to 0. And I'm going to take the second factor and do the same thing. So you can see the first equation is already solved. It tells me x is 0. On the second equation, I've got to do a couple of things. I'm going to add 3 to both sides, and then I'm going to divide by 4. So I have 2 answers, x equals 0 and x equals 3/4. And again, you could write those by separating them with a comma. All right, so that's the first type where it's already factored. Here's the second type where you see it is in standard form. You see the second degree term in the first position. You see the first degree term in the middle. You see the constant. And then you see the number 0 over on the right-hand side. So it's already arranged the way I want it to be arranged. So what am I going to do? First, I'm going to take this equation. I think I'll copy it down over here. And you want to be able to factor this. And since we've just spent a lot of time already talking about factoring, I'm going to assume that you know we're looking for two numbers that will multiply to give us a negative 18. And since it is a negative 18, we know that the two signs have to be different. So I think I'm going to go with this combination. I'm going to put the positive on the 3 and the negative on the 6 so that I produce a product of negative 18 and a sum of negative 3. And then taking each factor and setting it equal to 0 and solving, subtracting 3 from both sides there, adding 6 to both sides here, and so there are my two solutions, negative 3 and positive 6. So that's when it's already in standard form, but you have to do the factoring. All right, here's one that is not in standard form and it is not factored. So I'm noticing here that I've got x squared appearing first, negative 5x appearing next, and then here's the equals, and over on the right-hand side I have a 24. Well, I need to have a 0 over on that right-hand side, so I'm going to leave these first two as they are. I'm going to subtract 24 from both sides. Now that's what I'm doing right there. I'm subtracting that 24 from both sides. It gives me this new equation, equivalent equation, that is now in standard form. So I'm going to try and factor it, and again, assuming that you already know how to factor. I'm looking for a couple of numbers. That will multiply to give me a negative 24. That means the signs must be different. And will add to give me this negative 5 in the center. So I'm going to factor the left-hand side now that I have it in standard form. X and positive 3 and negative 8. Take each of those factors using the zero factor property. Set each of those factors equal to 0. So I'm going to be subtracting 3 from that equation on both sides and adding 8 to this equation, and here are my two solutions, negative 3 and positive 8. Okay, so that's when it was not in standard form and not factored. So let me show you one more type. This is the type where it's factored, but it's not equal to 0. So how do you handle one that's factored, but it doesn't equal 0 over on the right? In this case, it's equal to the letter x. So what I'm going to do with this one is use something called FOIL, which stands for first, outer, inner, and last. Let me copy this down again. So you're going to see me multiplying this left-hand side together using first, outer, inner, last. And let's see, I'll go ahead and combine these two in the middle. But that's still not in standard form, because in standard form you want it to have equals 0. So the next step I'm going to perform here is removing that x. I'm sort of lining that up so that the first degree terms fall in line with each other. So here's an x squared. This is going to be a positive 10x this is going to be a positive 24, and over here I have what I was looking for, which is a 0 on the right-hand side. So that's got it into standard form now. So let me see about factoring this, and again, we're looking for two numbers that will multiply to give me a positive 24 and add up to a positive 10. Since this 24 is positive, that tells me that the two signs have to be alike. So the combinations are 1 and 24, 2 and 12, 3 and 8, 4 and 6. So I'm going to go with the positive 4 and the positive 6 so that I get the positive 10 in the middle. And the positive 24 on the end. So setting each factor equal to 0. And solving, so I'm going to be subtracting 4 from this first one, from both sides, and subtracting 6. So my two solutions are negative 4 and negative 6. So that's a good place to stop to show you how to solve quadratic or second degree equations by putting them into standard form and then factoring and setting each factor equal to 0.